Very good morning to my dear computer students. But today we'll be continuing in our chapter number 9, that is data structures, and we'll be focusing today on the practical only, right? And the related theory I'll be discussing along with it. So we have discussed previously about the stack, how the stack is looking like this. So if there is no element in the stack, the top will be none, but if we start inserting or pushing the element inside the stack pointer will be incremented and decremented if we are taking out the elements or we are popping it. Okay, so as we are inserting an element into the stack, the pointer will get incremented by 1 and it will point to the new position or new index in the stack. Okay, here again we have added another element, so it is again incremented. Now top is pointing to a new position. Okay, similarly if we are decrementing it, how we can decrement it? By popping out the element. So if we are popping out 18 out of it, then it will automatically be decremented by 1. Why it will get automatically decremented? Because we will be giving command to decrement it, because the element has been deleted, so the top must point to the topmost element of the stack now. Okay, so if 18 has been removed, the topmost element is 32. Okay, again we are adding another element, so we are performing the push operation. So again the top will get incremented by 1, right? And again you can see if we are deleting one element, then top will get decremented by 1. Other way around, what we can do, we can calculate the top position of the top by calculating the length of the stack minus 1. Why I am saying minus 1? Because we are starting the index from 0. Okay, so here we can say ki what we are doing, we are just giving it an index 0. Okay, this is 0, and if we are adding another element, that will be given index 1. Okay, if there are, let us say there are two elements, you can see there are two elements, so how much will be the length of the stack? It will be 2, but the index of the 18 will be 1. Okay, this will be 0th index and this will be 1 index number 1. Okay, but the element is second, so size of the stack is 2, but top position is 1. Okay, top index is 1. We know that number of elements, okay, that will give you the total number of the stack size. Okay, stack size will be indicated by the number of elements. So if there are two elements, then the stack size would be 2, but the top will be pointing to 1. Why? Because we are starting from 0. Okay, you will see many times we are writing in the program top is equals to length of the stack minus 1. So length of the stack will be, here in this case the length of the stack will be 2. Okay, so if we are looking at ki there are two elements, the length of the stack will be 2 minus 1. Why we are doing minus 1? Because the top is not just equivalent to the stack size, it is minus 1 of it. Okay, the top will be length of the stack minus 1. I hope it is clear. So length of the stack is 2 here and minus 1 we are doing, so that means 2 minus 1 is 1. So top is now pointing to 1, index number 1. Okay. Here in this case also you can see if we have deleted one element, now top is pointing to 0th element. Okay, and how much is the size of the stack? 1. Why? Because we have one element inside it, but the top position, top index is 0. And how we are calculating 0? The length of the stack minus 1 we are doing, so 1 minus 1 is equals to 0. Okay, so the top will be now pointing to 0th element. So in this way we'll be calculating the position of the stack top in the program. I hope it is clear to you. So we will be doing different operations in the stack, as we have read also, like push, pop, and see, these were the various operations. Insertion means with the help of push function we can do it. Deletion means pop, and searching, though we will not be doing here. Here we'll be displaying the data, and we will be checking the peak. What we meant by this peak is doing the inspection, means referring to the topmost stack top element. Okay, so if your top is now pointing to 32, so if we will use this function peak that we are using here, that will give me 32 as output. Okay, so peak is to inspect the stack, that means to That means to check the topmost element of the stack. See, in this case, if we consider there are two elements, so size of the stack would be 2, and what will be the index of the top? It will be 0 and 1. Okay, so if we can calculate it with the help of the stack size, the length is an inbuilt function that calculates the number of elements inside the stack. Okay, so that will be 2 minus 1, so it will be 1. So top is now pointing to first index. We know it is 1 and it is 0. Okay, so this way we can calculate. Okay, so we have referred to overflow, underflow also. Overflow occurs when the size of the stack has been increased up to the maximum size. See, here in this case, in this program, we are not taking the size of the stack as fixed. See, if we will take the size of the stack as fixed, see, if we will close the stack like this, then that means we have a fixed size of stack. But we will not close the stack like this. We will keep a empty open stack like this, because we are not going to define the size of the stack initially. So you can enter n number of elements inside it. Okay, there will be no restriction of it, because if we are using like this key 5 elements you can enter, as we have taken this example, he has defined the capacity here 4. So after 4, fifth element when you are trying to insert, it will give you overflow, and for handling this type of situation we must give certain code, because otherwise it will do something wrong inside this stack. What wrong it can do means, if after this I try to insert an element, either you write print statement that it is overflow, and for that you need to keep on checking the size of the stack. Means once you are inserting one element, you need to check the maximum size of the stack has been reached. If not, then you can enter. Again, if you start entering another element inside the stack, then again the condition has to be checked, then again the condition has to be checked, then again the condition has to be checked. Means every time you are trying to insert element inside the stack, every time the condition has to be checked whether the maximum capacity of the stack has been achieved or not. Okay, so for that you need to write additional code. So we are not taking that in notice, this condition we will be avoiding using this condition. So for avoiding it, so that overflow may not occur, what we are doing, we are keeping the stack open. Okay, we are not defining the limit of the stack. Okay, size of the stack. So this will not give any problem in this particular program, but this we cannot avoid. Why? Because if the stack is empty, means if there is nothing inside the stack and still you are trying to remove one element out of it, so in that case underflow will occur. Okay, so underflow cannot be avoided anyways. Okay, so we need to handle it. Every time we need to check, whenever we are deleting something, every time we need to check whether the stack is underflow, or means stack is empty or not. Okay, so you can see in the program also many times I've used this return or underflow, and here also return underflow. So every time we need to check. Similarly, if we will clarify the size of the stack, then we have to check for overflow also. So we can avoid doing that, but we cannot skip checking underflow, because that will happen anytime. That can happen anytime when there is no element in the stack. Okay, so in the book you will find that he has described this stack as this, but in memory, in computer memory, it is stored like this only, but actually we are representing the stack like this in vertical manner. Okay, so don't get confused why it is showing vertically here and why it is showing horizontally here. The things are still same, but just we are trying to show that we are adding element from here only. Okay, so it will give you an appearance of queue, because queues are also implemented in this form. So don't get confused. Actually stack is for your convenience implemented as this, but in memory it is represented as that is why it is showing you like this only. It is one and the same thing, don't get confused. Now let me tell you how to perform these 3 operations, peek, push and pop on your stack. Okay, how to implement them. So if you want to check for the topmost element of the stack, then you need to go with stack top. This is the way to write or to refer to the topmost element in the stack, and we will be using it in our program also. Okay, so peak stack we are using to refer to the top. Okay, so here when the function definition has been given, you can see it like here he is giving stack top. Okay, the same function stack top. Okay, so here instead of writing stack he has written stk. Okay, so for referring to the peak of means the topmost element of the stack, we are using this particular way. Okay, next is push. When we are adding element inside the stack, for that we'll be using this append function. Append function, what it is doing, it is an inbuilt function, and that is actually adding element to the stack every time, because if we are not using this function, the element will not get added or pushed inside this given stack. Okay, so we will write stack dot append, and then we will write the item or the element that we are trying to put inside the stack. Okay, like we are putting A, we are putting B, C, and many other elements we are putting. So with the help of append function we can do this. And if we are trying to delete one element, so we need to write like this stack dot pop. Okay, so in this way we'll be able to just remove it, the given element. So now we'll be learning how to use this particular program, the implementation of the program. See, I have written this program already for you, because if I'll type it in front of you, that will take long much time. The video will be very much long, because explanation is also required along with it. So I have typed this program for you earlier. So let us now discuss. See, these are the function definitions. So we are trying to make different cases inside the stack. The main of the program will start from here, the stack, when we are initializing it. There is nothing inside the stack and we are initializing it. It is totally blank now, and top we are defining none, because it is not containing any element, and top initially is none. So as we have given the indication here also, the top is none. Okay, so you can see, so top is initially null and stack is empty. So the program execution, why I'm saying the program execution is beginning from here, because before that we are just defining the functions. See how many functions we have defined. My first function is isEmpty function, that will check whether the given stack is empty or not. If the stack is empty, stk refers to the stack only. Okay, in function definition, when we are using function arguments, okay, stk, it will refer to this stack only. Okay, this stack only we are referring to. Okay, so if the stack is empty, then it will return true, else the stack it will return false, means it is not empty. So if the stack is empty, this is the function that we have, these are the function that we are defining. Okay, so first function is I hope is clear, that is empty. We are checking whether the stack is empty or not. Second function would be the push function, that will give you an indication that you are going to insert an element inside the stack, like we are inserting the element like this. So for that I told you we will be using the append function. So how to use it? stk. See, here in push function we should have two arguments. First is your stack, where we need to put and what to put, that item. Okay, that means we are going to insert 32, we are going to insert 18, and so on. We will keep on adding elements inside the stack. So push function will help us in adding the items in the stack. So there are two arguments, one is your stack and second is your item. Okay, next we will be using this append function and will be giving item as an argument inside this append function, so that this item may be added to this given stack only. And once the item has been added, I told you the top is incremented, and how we are calculating the top, the number of elements minus 1. So length of the stack will be calculated. If there are two elements, so length of the stack will be 2 minus 1, so it will give you 1. So if there are two elements, then top is referring to index number 1. Okay, so I told you this point in explanation now only. Okay, so if it is not clear, please rewind the video and check out these steps again. Fine. Okay, then this push function will add this element with the help of this append function, and then it will give you the new position of the top pointer. Okay, Next is your pop function. Pop function will take out the element, means to remove the element from the stack. We are using this pop function. Here we were using two elements, two arguments. One was stack and second was item. Why we are not taking two elements here? Why? Because we need to pop the topmost element only. If we want to remove 32, firstly we need to remove 18, then we can remove 32. So always the topmost element will be deleted. So if you want to remove 32 also, so firstly you will apply pop for this, then secondly you will apply pop for this. So two times you need to use pop. Okay, so we are not in need to specify which element is to be removed. So we are just passing one argument inside it, that is stack. So when we will write pop stack, then it will eliminate or take out the topmost element of the stack that is present at the top. Okay, so we are checking before taking out any element. We must check whether the elements are present inside the stack or not. I told you every time we are popping out, we need to check whether elements are present. If elements are not present, even then we are trying to delete them, then there is a case of underflow, because there is nothing and still we are trying to remove, then it will give you underflow. So if we are removing in such a case where the elements are not present inside it, then definitely we should check. So for that we have used a function isEmpty. If the stack is empty, then the stack will return true, otherwise it will return false. So if it is true, means this is true, means the stack empty. When this function comes, it will go here only. So it will check whether the stack is empty. If it is true, then if it will come here. If true, so that means underflow hai. Right, if underflow is there, then we cannot delete. Okay, so in that case, so it will not work, underflow hi aa jayega. Then otherwise what we will do, item is a variable that is holding whatever you are taking out from the top of the stack using this StackPop. I have just shown you this function, how to remove element from the stack for StackPop. So we are using this particular way, or we can say operation, okay, that will help you to remove elements. So stack.pop function, okay, it is calling this function again and it is removing that item, the topmost element from the stack. Okay, now it is again, it will along with, if the element has been deleted, obviously the position of the stack top pointer will also be changed. If you have removed 18, now top will not point to 1, it will point to 0. So how to give new position to this stack? Again you need to check once the element has been deleted. So if length of the stack is 0, means one element was there and that you have deleted. Okay, so stack now length of the stack is 0, there is nothing, means there was 32 only and you have deleted 32. So length of the stack will now be 0. So that in that case the top will be none. Otherwise, if there is another element, means if it was not the last element, this is the case when this was the last element. Okay, only one element was there, then what we should do, top को हमें none बना देना. After deleting 32, the top will become none. Okay, otherwise means there were more than one element in the stack, so next position of the top will be -1. How we will be calculating? See, now 18 we have removed. Okay, now the elements inside this stack will be 1. Okay, so now we will be calculating the length of the stack. Like there were two elements like this and we have removed 18. Now there is one element, so 1 minus 1 is 0. So now it will be pointing to this 32 only. Okay, 0th element is 32 only. Okay, now top will be pointing to 0. Okay, if there were two elements, we have removed 18. Now the length of the stack is 1. So 1 minus 1, the length of the stack is 1. 1 minus 1 is 0. So now top is pointing to 0th index. I hope it is also clear. So whatever is the case, either this will run, means if either there will be one element only or there will be more than one element. So in the both cases we have given the position of the top now, and whatever item we have deleted from here, it should be returned. Okay, see, writing this return statement is very much essential and it will be followed once the item will be, see this is related to this only, this else is related to this return, matlab this return statement is related to else, it is not related to this else. Okay, so this please mind it very well. If you will not place this return statement, see by default this return statement will come here. Okay, when you will press enter here, so you can see here also, if you will press enter it will come here in this else, but it is not under this, it is under this only, else. Okay, so either if will be executed or else will be executed, so whatever the result we are obtaining from this means out of these two will be ultimately be item will be resulted. Mean these two cases are just to update the pointers, top pointer, and this item we are getting from here once we have performed the pop operation. Okay, so next is your peak operation. Now this peak will be actually showing you the topmost element on the stack. Only for that you need to return stack top. Okay, I have already told you, we have discussed that for showing the topmost element stack top you need to write. So we are writing the same. And what will be the value of the top? Okay, for that length minus 1. Okay, see like this is the case. Here we have two elements, so now top is 2, oh sorry 1, and length of the element, I mean the stack is 2. Length of the element is 2 because there are two elements and top is pointing to index number 1. Okay, so you can see the length of the stack is 2 minus 1 is 1, so top is pointing to 1 only, right? In this way we'll pointing out the top is 1, and here, so it was top is equal to length minus 1, so it will be 2 minus 1 is 1, so top is pointing to first index and the element at the top is 18 here in this case. Okay, similarly we have another function, that is display function, that will display the contents of the stack. Fine, so for that what we need to do, we need to check whether the stack is empty. If the stack is empty, again see this is the same function that we have defined here, so always we are checking whether we are trying to display, and if the stack is empty we can't display anything, so we need to check always. Okay, is empty, then we can say stack is empty, we can't display anything. If there are contents inside the stack, then the top will always be calculated with the help of this length of the stack minus 1, otherwise means whatever the position of the stack top is, according to we will print the top. Okay, so top, whatever the top is pointing to, like let us say there are two elements, so 2 minus 1 is 1, so top is pointing to, let us say 18. Okay, so it will print stack top, and this is printed just for indicating you that this is the stack top. Okay, I'll run this program for you. Okay, and whatever, see we have taken 3 arguments here, top minus 1, why we are taking top minus 1, because whatever is the top, like this is, we have to start from it and we have to go up to minus 1. See we are decrementing every time by minus 1, because see we need to print the values of the stack. So firstly 18 will get printed, then 32 will get printed, so in this way we will be printing out the stack. So initially the top will be 1, then once we have printed it, the top should be decremented by 1, so minus 1 will keep on doing. Like another, like we have 11 and we have 10. Okay, so let us say we have 4 elements, so initially means 32 will get printed first. Okay, then 18 will get printed. Okay, then 11 will get printed, and then 10 will get printed, and the top is pointing to 10 only. Okay, so top minus 1 से शुरू करेंगे हम, and we will keep on printing it minus 1 तक. minus 1 क्यों ले रहे हैं बेटा? Because the last जो है आपका इंडेक्स इज 0, बट minus 1 हो जाएगा, तो इसका मतलब जो स्टैक है वो empty हो चुका है. So that is why we are taking minus 1 here, because we will be up to 0 to we need to print. Okay, this will be 0, this will be 1, this will be 2, this will be 3. So up to 0 to we need to print the elements, right? But minus 1 will indicate now the stack is empty. Okay, so minus 1, firstly this minus 1 is the index. Okay, and this minus 1 is the decrementation. Okay, So that is why we have taken 3 elements here. And print stack A means whatever is at the A. Why we are taking A? Because here we have taken A. Okay, and in this A will be referring to the top of the element every time. Fine, this way the stack will get printed. So now these all functions, see how many functions we have made. One is your display function, second is your peek function, third is your pop function, fourth is your push function, and fifth is your isEmpty function. Okay, so 5 function we have defined. So these were the function definition, and we know very well until the function definitions are there, this is not considered to be the main part of your program. So your execution of the program will actually begin from here only. These were the function definitions. They will be ignored just looking after the function definition statement only. Okay, so beta, here the execution will start. Initially the stack is 0 and the top is none. So we have put all the things inside this while loop, and we have made it true. Why true? Because until the conditions inside it will not go false, it will keep on running. Okay, until you will not press exit, this program will keep on running. So we have given a termination point with the help of this 5th point. Okay, so just to let you know how many cases we have made, we have used this print statement. So 5 cases we have inside it. First case will be for the push, pop, third will be for the peek, fourth will be for displaying the content of the stack, and fifth will be for exiting. Okay, so firstly you will enter your choice from 1 to 5, and if you are not using the numbers between the 1 to 5 range, so 5th case will get executed. Okay, and that will be ch is equals to 5 and break. Okay, this will take you out of the actually, if you are not using this out of these 5, then else will be executed and it will tell you that this is an invalid choice that you have entered. And if you are not using the any other, means if you will use 1, 2, 3, 4, so different cases will be executed. If you are pressing 5, that means you want to come out of this while loop, then you need to press, for coming out of the while loop you need to press 5, or other than 1 to 5 if you will press anything, then it will show you invalid choice. Okay, so now let us discuss these cases one by one. So if ch is equals to 1, if you have pressed 1, so 1 is for the push. Okay, so whatever item you want to enter, ठीक है, आप वो आइटम में दे देंगे with the help of this input function. Okay, stack, तो initially it is null, so stack के ऊपर हम item डलवा देंगे तो push के through हो जाएगा, right? Then whatever item you want to pop out, तो हमने second case ch is equal to 2. If you want to perform the pop, means you want to remove elements, then you will press 2. If you will press 2, तो ch is equals to 2. These switch cases sort of like we have done earlier also. Okay, so we are using multiple if statement, elif statements to use the different functions actually. Okay, so if means if the item that you are trying to delete is there is nothing inside the stack, then it is underflow only, so it should print stack is empty. Otherwise it will pop out the element and it will print it whatever element has been popped out. Okay, and ch is equals to 3. Ch is equal to 3, what it means, third case was to check the topmost element of the stack, that is peek. So for that we are calling this peek function. See, we are calling this function push. Here the push function will be called, and where we have given the push function definition, here is the definition for push. Okay, so when the function call is there, it will come here directly. Okay, so if you are selecting ch as 1, so this push function will be executed. The definition has been given here, you can see, I have explained it to you. Okay, if you are selecting ch as 2, okay, then the pop function will get executed. When this function will be called, it will go here and it will perform this pop. Okay, so this whole body of the pop statement will be executed up to here, and the element will be removed from the stack. Okay, next is your peek function. If you select case 3, okay, then peek function will be executed. So this is the function call, it will take you to function definition. This is your function definition for peek. Okay, it will show you the topmost element. And then fourth is, if you are selecting ch as 4, then it will use the display function. Okay, this is a function call, and it will take you to the function definition of this particular function here, and this complete function will get executed to display you the output of the contents of the stack. Okay, and if you press ch is equals to 5, then it will take you out of the program. Now let me execute this program for you. Okay, so for that I'll be running it. Okay, so it is showing you all the 5 choices. So firstly, if I need to push an element, I'll be pressing on 1. Okay, as I will press enter, it is asking me what element you want to enter. So let us say I want to enter 45. So again it is asking me what next you want to do. Now again I want to add one more element. Okay, so I'll be clicking on 1 again. I'll be entering 34 now. So now we want to see the content of the stack. Okay, so how we can see the content of the stack? Actually the screen is not showing the bottom part of it. Actually I have pressed so that is why it is not showing. Let me show you again. Let me run it again for you. So this is our program. I'm now trying to run it again for you, so that you may be able to see everything that is happening on the screen. So now I'm giving again 1. So enter the element. Again it is asking I want to enter another element, so I'm pressing push for 1 for push. Okay, so it is asking me to enter the element again, so I'm adding for 56 now. Okay, so that has been added. Okay, let me check whether the entries has been added inside the stack or not. The elements 56 and 23 has been added or not, and how I can check with the help of this display function. So I should press choice number 4. Okay, now see, here you can see. So what I have added 23 and 56, and what is my topmost position? This is top. Okay, 56, this is my top position. Okay, now if I want to enter another element inside the stack, for again I need to perform push, so I'm using first choice again. Okay, I'll be adding 45 this time. So beta, again that would have been added. Okay, now again let me add another element in the stack. So for that I'll be selecting 1. Now adding 78 element to it. Okay, now I want to see what is the position of the stack, status of the stack, and to show it I will select this display option. So fourth option I have given, enter. Oh, sorry, by mistake 44 I have pressed So you can see. So now there are 4 elements, 23, 56, 45 and 78, and top is pointing to 78. Okay, I hope you are clear with it, that whatever elements we are entering with the help of this option number 1, that are being added to this stack. So this is our stack, and you can see the topmost position will be where the last element has been added. Now let us perform pop. Okay, you are clear with the push now, I think, and now we'll be taking you to the pop. So for pop I should select the option number 2. So right now I'll be pressing 2. So let us pop. So you know the topmost element is 78, so when I will perform the pop operation, the 78 will be removed from the stack. So see, it has shown you a message, popped item is 78. So 78 has been removed. Now you want to see the current status of the stack. How you will be able to see? See, either you use this peak. Now see, if we have removed 78, then top would have been decremented and it would have been pointing to 45. Okay, so let us try this option now. So I'll be pressing 3 option this time. So the topmost element is now 45. Why 45? Because 78 has been removed. And now again we want to check using the fourth option, that means display. We want to see the status of the stack. So you can see there are now 3 elements in the stack and top is pointing to 45. Okay, so pop is removing the topmost element as we have removed it. Now let us try removing another element. Let us say we want to remove the topmost element again, 45, and if you want to remove 56, then 45 has to be removed, then 56 can be removed. So means 2 times pop you need to perform. Okay, so if I perform pop again using this second option, so you can see popped item is this, and if you want to check the topmost position, for that you need to press the third peak option. Okay, sorry, by mistake it is done. So now you can see the topmost position is 56. Why 56? Because 45 has also been removed. It is giving you popped item is 45. Now the topmost item is 56. So it is showing you the topmost item is 56. You want to see the stack. Okay, so 4 I'll be pressing out. Now you see there are 2 elements left inside the stack, and it is top is this. So I'll be again giving pop. So now you see 56 has also been popped out. Okay, and we want to check the top position, sorry, topmost position, that is 23 topmost. Okay, now again we are performing the pop operation. So popped element is 23. Now you want to see the topmost element of the stack, using third option we can do it. So what is saying, underflow stack is empty now. Now you want to see the stack status. So what is it is saying, the stack is empty. There is nothing inside the stack. I hope it is clear to all of you. Please beta, you need to do this practical in your file. So please check out this video n number of times until the concepts are clear to you. Thank you so much.